The volume of the truncated cone. A truncated cone is just a cone with the top chopped off. So to find the missing dimension here, we're going to label it x. We can set up a ratio for finding x by comparing the distance of the piece to the distance of the hole. So the radius of the piece is 2, and the radius of the hole is 5. We're going to do the same thing with x being the piece, and the whole distance is x plus 6. Cross multiplying, we get 2x plus 12 equals 5x. By subtracting 2x from both sides, we are left with 12 equals 3x, which means x has to be 4. Then the volume for the whole cone would be 1/3 pi r squared times h, or the height, and the height is 6 plus that piece, which is 4, so their height is 10. That leaves us with 1/3 pi times 25 times 10, which is 250 over 3 pi. But the other piece is 1/3 pi r squared with a radius of 2 and a height of 4. So that is 1/3 pi with 4 times 4, which is 16 over 3 pi. The truncated cone is missing that top part, so we are going to subtract the top part from the whole. 250 minus 16 gives us 244 over 3 pi, units cubed because it's in volume. 234. And if you want to, you can reduce that. 234 is divisible by 3, but you do not have to. A truncated pyramid is done the same way by setting up a ratio of the part to the whole and the part to the whole. Cross multiply. 10 times x is 10x. 3 times x is 3x. And 3 times 14 is 42. Solve it for x. So the whole distance is 6 plus 14, which is a height of 20. So our whole volume would be 1/3. The base area, which would be 20 by 20. And the height was also 20. 14 plus 6 was 20. Giving us an entire volume for the pyramid of 8,000 over 3. But we're missing that top part. And the top part is 1/3. Its base area would be 6 across and 6 wide, so 6 times 6. And its height is also 6. Which is 216 over 3. We are missing that top part, so 8,000 over 3 minus 216 over 3 is 7,784 over 3 units cubed because it is a volume.